In this video, we'll be finding the mean and variance using the maximum likelihood estimation for the Gaussian noise distribution. For more on this topic, you need to subscribe to this channel. Solution. Using the maximum likelihood estimation, the first thing to do if you're given any distribution is to take the likelihood function. So the likelihood function of the given Gaussian noise distribution is equal to the product sum of 1 all over square root of 2 pi sigma squared exponential negative yi minus mu raised to the power of 2 all over 2 sigma squared. The likelihood function, which is the product sum, is equal to, if we take the product sum, we get 1 all over square root of 2 pi sigma squared, the first one, exponential negative yi minus mu squared all over 2 sigma squared, multiplied by 1 all over the square root of 2 pi sigma squared, the second, exponential negative yi minus mu raised to the power of 2 all over 2 sigma squared, multiplied by, it continues like that to give us 1 all over square root of 2 pi sigma squared raised to the power of n exponential negative yi minus mu raised to the power of 2 all over 2 sigma squared. So this is what we get if we take the product sum of the whole of this. It then means we can write our likelihood function. Our likelihood function of yi, the mean and the variance, is equal to now give us 1 all over square root of 2 pi sigma squared raised to the power of n exponential. Because we are taking the product sum, this becomes summation of yi minus mu raised to the power of 2 all over 2 sigma squared. So this is what we get. This is what we get. The next thing to do is to take the log. But before taking the log, we have to rearrange this well so that it will be very easy for me to take the log. So rearranging this, our likelihood function will be equal to 2 pi sigma squared raised to the power of n all over 2 negative n all over 2 exponential negative summation yi minus mu squared all over 2 sigma squared. We can still rewrite it. We can rewrite our likelihood function to be yi, the mu and sigma squared, to be equal to 2 pi. We separate 2 pi, n all over 2. We also separate sigma squared raised to the power of n all over 2 exponential negative summation yi minus mu raised to the power of 2 all over 2 sigma squared. So this is what we get. Now, it is very easy for we to take the log. To take the log rating, we write take the log. If we take the log, we get the log of the likelihood function of yi mu and sigma squared will be equal to, if we take the log of this will come over here to give us negative n all over 2 log 2 pi. If we take the log of this, we'll have negative n all over 2 log sigma squared. If we take the log of this function, we get the same function. That means if you take the log of an exponential function, you get that same function. So we write negative summation of yi minus mu raised to the power of 2 all over 2 sigma squared, I running from 1 to n. We take this as our equation star because we'll come back to this. So we take this as our equation star. The next thing to do is to take the derivative with respect to mean to get the estimate of our mean. Also, we take the derivative with respect to sigma squared before we can get the estimate of our variance. So, we say differentiate with respect to the mean. If we differentiate with respect to the mean, that means the partial derivative, we get the differential of log of the likelihood function of yi mu and sigma squared all over the mean, which is equal to, if we differentiate this, since there is no parameter for the mean, it becomes 0. So we have this to be equal to negative 0. Likewise here, since there is no parameter for the mean, we get what? Negative 0. Here, if we differentiate this, we have negative 1 all over 2 sigma squared. This 2 will come over to this place to give us negative 2 summation yi minus mu 2 minus 1. And from composite function, you know that we also differentiate what is inside to give us multiplied by negative 1. So it then means that our derivative can be written as, we come over to this side. So we want to write this our derivative, what it gave us. Coming here, we'll write it as for more on this topic, you need to subscribe to this channel. So our derivative of the log likelihood function of yi mean and variance will be equal to 2 summation of yi minus mu raised to the power of 2 all over 2 sigma squared. This will cancel this. So the next thing to do, we say equate to 0. Equate to 0. Equating the whole of this function to 0, we get summation of yi minus mu. Okay, this gone. 2 minus 1 is 1. So we have all over sigma squared to be equal to 0. Of course, it then implies that summation of yi minus mu is equal to 0 because this multiplied by 0, it goes. So we can open the bracket. We can open this bracket. Opening this bracket, we have summation of yi minus, if you sum a constant, you get n times that constant, which is equal to 0. So this can go over to this side, which is summation of yi to be equal to n mu. It then means that if we make the mu our subject of formula, we get it as our estimate to be equal to 1 all over n summation of yi. So this becomes our estimate of the mean, the estimate of the mean. The next thing to do is to look for the variance. How do we look for the variance? We move over to the other side. We move over to this side. This is our mean. We have gotten it. Now we move over to where we can get our variance. Of course, like I said, we'll come back to this equation star. So we say to obtain the estimate of sigma squared, we recall from equation star. From equation star, we say differentiate with respect to sigma squared. So from this equation, we differentiate with respect to sigma squared. Of course, the whole of this will give us 0 because there is no parameter for sigma squared here. So we have differential of the log likelihood function yi minus mu, yi mu and sigma squared all over the sigma squared. So we are differentiating with respect to the sigma squared to find our estimate. Of course, the whole of this will give us negative 0. The whole of this, we have sigma squared here. So if we differentiate this, we have negative n all over 2 sigma squared. We can now delete it. Then we also have minus this function. How do we differentiate this? Very easy. We can use the partial derivative or the quotient rule of differentiation. This function, let us write it out. We have it as summation of yi minus mu raised to the power of 2 all over 2 sigma squared. So we can delete the whole of this. We don't need it. For more on this topic, you need to subscribe to this channel. So this will become our u and this will become our v. For the quotient rule, we know that v the u all over this time the sigma squared minus u the v all over the sigma squared is equal to, this is equal to, we bring down our v is 2 sigma squared, the u all over the sigma squared. If we differentiate sigma squared here, there is no parameter for sigma squared, so it becomes 0 minus, we bring down u is this, which is summation of yi minus mu raised to the power of 2. Then the v all over the sigma squared, that means this. If we differentiate this, we get multiplied by, since we are differentiating with respect to sigma squared, we get just 2 all over v squared. For the quotient rule, all over what? V squared. So this v squared will now give us 2 sigma squared raised to the power of 2. So if we rewrite this, this is equal to, this 2 will come over to this side to give us negative 2 summation yi minus mu raised to the power of 2 all over, this will give us 4 Okay, if we put 2 here, it becomes what? 4. So this is what we get. Okay, that means that these 2 can cancel to give us 1. This can cancel here to give us what? 2. So we'll write it here, which is negative summation yi minus mu raised to the power of 2 all over 2 sigma 4. So this is what we get. Okay, that means that our derivative for the log likelihood function of yi mu and sigma squared all over the sigma squared will be equal to the whole of this, which is negative n all over 2 sigma squared. Negative will give us plus summation of yi minus mu raised to the power of 2 all over 2 sigma 4. So this is what we'll get. The next thing to do is to equate to 0. So we equate the whole of this function to 0. For you to maximize this function, you equate it to 0. So equating to 0, we still move over to this other side of the board. For more on this topic, you need to subscribe to this channel. We have our estimate for mean to be this. We can leave it. So equating that to 0, we have negative n all over 2 sigma squared to be equal to negative summation yi minus mu raised to the power of 2 all over 2 sigma 4. So this can come over here, this will cancel this. This can come over here to give us 2 sigma 4 all over 2 sigma squared to be equal to summation of yi minus mu raised to the power of 2 all over n. Of course, this will cancel this. The whole of this will cancel this to give us 2. It then means that our sigma squared estimate will be equal to summation of yi minus mu raised to the power of 2 all over n. So this becomes our variance. This becomes our estimate for variance, and this becomes the estimate for the mean. This is how we can obtain the maximum likelihood estimation for the mean and variance of the Gaussian noise distribution. So for more on this topic, you need to subscribe to this channel.